Hello student, in this video I am going to discuss how to factorize a polynomial by using hit and trial method. Let us take few examples. I have a cubic polynomial x cube minus 2x square minus x plus 2. This we want to factorize. If a cubic or biquadratic polynomial given to you, this method, hit and trial method, work easily. Let us start with this problem. In the first step, we consider polynomial as p of x and check the constant term. Constant term, in this case it is 2. So what we are going to do here, we are going to check all possible factor of a 2. All possible factor of a 2 means this 2 is divisible by 1. It is divisible by minus 1, 2 and minus 2. So we check the factor. After checking a factor, in the first step we will substitute the value of x1 in the polynomial. We want to find the zeros of this polynomial. If we substitute x equals to 1, you will get 0. So by substituting the value of x as 1, you get the value of polynomial as 0. It means x equals to 1 is 0 of this polynomial. In any case, by substituting x, you will not get 0, then you will substitute minus 1. If you did not get 0 with minus 1, you will substitute 2 and minus 2 respectively. Definitely in any one of the cases, you will get 0. So in the first step, you have to find 0, and when we find the 0, you observe here x equals to 1 give us the 0. It means x minus 1. Shifting 1 to left hand side, you get x minus 1. X minus 1 is a factor of p of x. This is from the factor theorem. In the second step, this x minus 1 will divide p of x exactly. We will perform the division. We perform the long division, and by performing the long division, in this case x minus 1 will divide p of x exactly, so your remainder should be 0. If the remainder is not 0, then you have to check the steps of a division or check the previous step again. In the next step, when you do division, this is the quotient, you get x square minus x minus 2. Now by doing the division, this cubic will be reduced to a quadratic polynomial. This quadratic polynomial has to be factorized. It should be factorized, and we know that how a quadratic polynomial will be factorized. It will be factorized by middle term splitting, as we discussed in the previous video. So in the next step, we'll factorize this polynomial x square minus x minus 2. Here the product is minus 2 and sum is minus 1. As you know the middle term splitting, the possible factor is minus 2x plus x minus 2. Taking common, we get the factor x plus 1 and x minus 2. So finally, all the factor of our polynomials, these factors are x minus 1, which we got in the previous step, and the two factors we obtained by middle term splitting. All the factors are x minus 1, x plus 1 and x minus 2. These are the all possible factors. Since this is a cubic polynomial, so number of a factor should be 3. Let us discuss another problem. This is x cube minus 3x square minus 9x minus 5. The process will be same. Consider polynomial p of x, and here the possible factor of 5, 1, 5, minus 1, minus 5. Substituting x1, you will not get 0. Then we have to move on to minus 1. By substituting x minus 1, you will get 0. So it means x equals to minus 1, means x plus 1 is a factor of p of x. The second step, you do the division. You perform the division. By performing division, you get x square minus 4x minus 5. Third step is middle term splitting of this quotient x square minus 4x minus 5. By performing middle term splitting, you get the factor x plus 1 and x minus 5. And all the factors are x plus 1 and x minus 5. Here x plus 1 repeats 2 times, means factor can be repeated, factor can repeat. So basically this question carry 3 steps. First step, finding 0. Second step is the division step. Third step is middle term splitting. Let us discuss one more problem. This is x cube plus 13x square plus 32x plus 20. Consider polynomial p of x and here last term is 20. The positive factor over 20 are 1, 2, 5, 10 and 20. Now here one thing you have to observe carefully, if I'll substitute the value of x 2, 4, 5, 10 and 20, we never get 0 because all coefficients are positive. Positive term, by substituting positive term we never get 0. So try to substitute negative. I substitute x minus 1, we did not get 0. By substituting x minus 2, we will get 0. So means x equals to minus 2, or we say that x plus 2 is factor of p of x. Second step is a division step. By dividing you get x square plus 11x plus 10. Third step is factorization, x square plus 11x plus 10. The product and sum you identify and do the middle term splitting, you get 3 factors. Now let us try a biquadratic polynomial. In biquadratic polynomial, this is x4, it is 2x4, it means it certainly give you 4 factors. So we identify all those 4 factors. So what are the steps we follow? First we try to find two zeros, 2 factors by hit and trial method. Let us do it. Considering polynomial p of x, here constant term is 6, so possible factor is 1, 2, 3 and 6. X is 1, we will not get 0. Substituting x minus 1, we will get the 0, and we try to find one more 0, so we'll substitute. Here we get x plus 1 as a factor. Now x will substitute 2, we did not get the 0. By substituting x minus 2, we get 0. Now it is important to understand here the two factors we get, one is x plus 1 and the second is x plus 2. Now for the division, we will multiply them, x plus 1 and x plus 2, we get x square plus 3x plus 2. This will divide this polynomial, given polynomial. When we do the division, quotient will be quadratic, and quadratic can be solved easily by using middle term splitting. So let us divide this polynomial. After performing division, you get 2x square minus 5x minus 3. And you have to factorize this by middle term splitting. By performing that, all the factors, here 2x plus 1 and x minus 3 are the two factors, and the other factors are x plus 1, x plus 2, 2x plus 1 and x minus 3. So this is the way a biquadratic polynomial can be factorized. Let us try one last problem from this topic. If x minus 2 is a factor of this polynomial, find the value of a k and hence factorize the polynomial. Now if you read the question carefully, x minus 2 is a factor, so we can find the constant k easily, and then we follow the same process. First step, considering polynomial p of x, substituting x minus 2 0, finding x here, and this condition p of 2 is equals to 0. By solving this, you will get the value of a k, and k comes to be 3. K is 3. This value of a k, when you substitute as 3, this will substitute in the polynomial now to change this to the standard form. So x minus 2 will divide p of x exactly. This k is substituted as 3. By performing the division, you get 2x square plus x minus 15 as quotient, and you factorize this. So all factor of polynomials are x minus 2 and 2x minus 5 and x plus 3. So there are some practice problem related to this topic. Thanks for watching this video.